Hi, today we are talking about a new parser which is categorized under top-down parsing. Its name is non-recursive predictive parser. Another way we can call this same parser as LL1 parser. And I already told it's a top-down parser. So the construction of parse tree is starting from root to leaves and top to bottom. And it is free from backtracking as well as recursion. So this parser explicitly using a stack to remove the recursion, and also it is using a parsing table, and which will help the parser to parse the given string and construct the parse tree based on the parsing action. So that's why it is called a table driven parser. Yes, this LL1 parser, let me know a little more about LL1 parser. So LL1, this the last within bracket 1, you can see that 1 stands for number of look ahead symbol. That means the number of symbol this parser referring to decide the action for a given input symbol and a given non-terminals. And the next here it is only one input symbol it will scan at a time. The next L stands for this parser using or constructing leftmost derivation to verifying the given string is formed based on the rules of the grammar or not. And the first L it is stands for left to right scanning of the input string. So even though whether it is top down or top bottom of parser, the scanning of the input will start from leftmost to and it will proceed towards rightmost. So that is this L and 1 stands for. Any parser need a grammar to construct the parse tree for a given string, and the parser usually verifying whether the string belongs to the language of the grammar. So the LL1 parser using a grammar LL1 grammar, and if the grammar is not LL1, then we can't construct LL1 parser. The minimum criteria for having a grammar become LL1 is it should be free from left recursion and the grammar should be left factored. There are certain other conditions, but these two are the requirement for having a grammar is LL1. And what is the model of LL1 parser? Let us see this picture. Model of a table driven predictive parser. See, this is the informal description of the LL1 parser. Here in this LL1 parser there is a tab that is called input buffer, and this tab is divided into many cells, and each cell hold one symbols. So here you can see that the input symbol is A plus B, and this input symbol is ending with the dollar symbol. So this dollar symbol is a special symbol which is not present in the terminal set, and this which will be used for understanding the end of the input string. Then it has a predictive parsing program, and that program will help the parser to perform the action based on the input from input buffer, stack top and parsing table. So this is the core of the parser, and which will read the input from input buffer, stack top, and based on that it will refer the parsing table and perform the action based on the content obtained from parsing table M. So you can see that there is one stack. So initially the stack bottom end marker is a dollar symbol, and the stack is used for storing some non-terminals, and the stack top symbol predictive parser will read to decide the action performed. Then there is a parsing table M. It's a two-dimensional table where the rows are identified by using non-terminal symbols of the grammar, and columns are labeled by using symbols from terminal set. So one entry in the parsing table we can refer by using M of A in small letter a, where A is a non-terminal, A is a non-terminal, and small letter a is a terminal symbol, non-terminal symbol. So, M of capital A small letter a contains some production, and parser will use that production to perform the action. Yes. Then the last one is the parser will produce an output if the given string is of the form W dollar. W is the input string and ending with dollar, and this parser will verify that W belongs to the language of the grammar. Yes, we are constructing LL1 parser for the grammar G, and the language recognized by the grammar G is L of G, and if W belongs to L of G, then it will tell yes, that means parser can successfully construct the parse tree from top to bottom, and the given string belongs to the language of the grammar. If W not belongs to L of G, then parser will give error. That means the parser can't construct the parse tree for the given string W. So this parser will produce leftmost derivation of the given string by constructing the parse tree from top to bottom. Yeah. Now we will focus on how to construct a parsing table, and there is an algorithm. That algorithm we can use to construct parsing table. So after constructing parsing table, so in another video I will explain how we can parse a given string and what is the predictive parsing program. Yes. So construction of a predictive parsing table. It's an algorithm, a simple algorithm. So let us look into this algorithm. So the input is a grammar G, and I already told this grammar should be LL1, then only you can construct a parsing table, and output is a parsing table, a two-dimensional table where columns are labeled by terminal symbols, rows are labeled by non-terminal symbols, and methods. So what is the steps in that algorithm? Look at here. For each production, A gives alpha of the grammar, do the following. For each terminal A in first of A in first of A, add A alpha to M of A small letter a. Second step is, if epsilon is in first of alpha, then for each terminal B in follow of A, add A alpha to M of AB, where A is a non-terminal and B is a terminal symbol present in follow of A. Full stop. If epsilon is in first of alpha and dollar is in follow of A, then add A gives alpha to M of A dollar. Yes, A is the terminal, non-terminal, and dollar is also included in the table construction, and order will represent one column. Yes. So here we will look into how this algorithm will work with a concrete example. E gives T E dash gives plus T E dash or epsilon, T gives F T dash gives star F T dash or epsilon, F gives within bracket E or ID. So this is our famous grammar. We know that this is our expression, arithmetic expression grammar, and this grammar is obtained after performing left recursion and left factoring on the grammar. I have written here E gives E plus T or T gives T star F or F gives within bracket E or ID. So this is the grammar, initial grammar G, and we have performed left recursion and left factored that grammar, then you will get this grammar. Yeah. Then here you can see that non-terminals are E, E dash, T, T dash and F. Terminal symbols are plus, star, left bracket, right bracket, ID. So the table is a two-dimensional table. So it's look like this one. Non-terminals are E, E dash are labeled by rows, and columns are labeled by terminal symbol, plus one more symbol we have used, that is dollar. So plus, star, left bracket, right bracket and IDs are all terminal symbols in the terminal set, and dollar is a end mark. Then one by one we can see how this table we can fill by using the above algorithm. Yeah. So the first rule present in the grammar is E gives T E dash. Yeah, this is of the form A gives alpha, where A is E, alpha is T E dash. Then the rule 1 is saying if A present in first of capital A, then we need to compute what is the first of E. First of E is, we already computed, first of E is, we need to compute first of T, and first of T we need to compute first of F, first of F we need to compute first of left bracket, and first of ID. So this is what first of V, and if you have doubt you can refer the previous video. So first of V contain two terminal symbol, left bracket and ID. Then according to the first rule, for every terminal symbols present in first of E, we need to add A gives alpha, that means E gives T E dash to the entry M of, here A is E and small letter A is left bracket, here we need to add E gives T E dash, E gives T E dash, and M of E ID we have to add E gives T E dash. Okay, so I will add here E left bracket, so here I will add E gives T E dash. Similarly, E gives ID, here also we will add E, and M of E ID we will add E gives T E dash. Okay, fine. Then next rule is, E dash gives plus T E dash plus T E dash. And the above rule E gives T E dash, we can't apply second rule. Why? Because here epsilon is not present in first of T E dash. If you compute first of T E dash, you will not get epsilon. So that is why we can't apply epsilon in second rule in this production. So that's why I have taken this production E dash gives plus T E dash. Here first we will apply rule 1. Rule 1 is saying we need to compute first of E dash. First of E dash contain plus. First of E dash contain plus, because we know that here first of E dash is first of plus T E dash. So first of plus T E dash contain only plus. So as per our first rule of the algorithm, M of E dash plus, we need to add the production E gives plus T E dash. Yeah, fine. So I will add that one. M is E dash plus, we will add here E dash gives plus T E dash plus T E dash. Then next rule is E dash gives epsilon. E dash gives epsilon. Here we have to compute what is first of E dash. By applying rule 1, we need to compute what is first of E. First of E is nothing but epsilon. Okay, first of E is epsilon. So rule 1 we can't apply. Yes, so first of E dash is equal to epsilon. So we need to apply rule 2. So rule 2 is saying that if epsilon is present in first of alpha, then for each terminal B in follow of A. So our production is E dash gives epsilon. So we know that what is first of E dash, which is equal to set contain epsilon. Then second rule is telling that epsilon is present in first of alpha. So here alpha is epsilon. So first of epsilon is equal to first of epsilon is equal to epsilon. Okay, set contain epsilon. So rule 2 we can apply. Epsilon is present in alpha. Then for each terminal B in follow of A. So we need to compute what is follow of E dash. Follow of E dash is a set consists of dollar in right bracket, yeah, B in follow of A, add A alpha to M of E dash, and so first I will add this one, right bracket. Here we need to add E dash gives epsilon. Then if dollar is in, look at the rule, it's saying dollar is in first of alpha and epsilon is in first of alpha and dollar is in follow of A, then add M of A dollar, A means E dash dollar contain production E gives epsilon. So these two we will add in here. M of E dash right bracket, here we need to add E dash gives epsilon, and M of E dash dot are also here, also we will add E dash gives epsilon. That is solved. The next production is T gives F T dash. Then here first we will compute first of T. First of T is equal to left bracket ID. Then rule 1 of the algorithm is telling that M of T left bracket, here we need to add T gives Ft dash as well as M of T ID, here also we need to add T gives Ft dash. So we will add that one. M of T left bracket, here we need to add T gives Ft dash. Then next one is M of T ID, here also we need to add T gives Ft dash. Okay, then we will check whether second rule we can apply or not. If you want to apply second rule, then we need to compute first of Ft dash. Ft dash is left bracket and ID. Here there is no epsilon. Epsilon is not belongs to first of Ft dash, so we can't apply second rule. The next rule is T dash gives star F T dash. Okay, so this is the next production. So here first we will compute what is the first of T dash. First of T dash is star and epsilon. First of T dash contains star and epsilon. Then our rule is telling M of T dash and star, where we have to add T dash gives star F T dash. Okay, so T dash star, here we will add T dash gives star F T dash. Okay, so there is no field corresponding to M of T epsilon, so that's why we can't add there. But we need to compute whether we have epsilon is in first of star Ft dash. So this contain only star. Okay, only star, so we can't epsilon is not there, so we can't apply rule 2. The next rule is, next production is T dash gives epsilon. So T dash is epsilon, so first of T dash is equal to first of epsilon, which is equal to set contain epsilon, so only epsilon. Then we need to compute what is first of epsilon. First of epsilon, we know that epsilon, so epsilon is present in first of alpha, that means first of epsilon, so we can apply rule 2. Rule 2 we can apply. So rule 2 is telling here, rule 2 is telling if epsilon is present in first of alpha, then we need to compute what is follow of T dash. follow of t dash is a big set contain plus dollar right bracket. Three members are there. So first we will accept this dollar. We will add these entries. First of t dash plus, here it contain t dash gives epsilon, m of t dash right bracket, there also contain epsilon, t gives epsilon. The next thing is okay, first of alpha contain epsilon, that means first of epsilon contain epsilon, and follow of t is contain dollar. So we can tell that m of t dash dollar also contain t gives epsilon. So in three places we need to add m of t plus, here we need to add t dash gives epsilon, then m of t right bracket, here also we need to add t dash gives epsilon, then m of t dash dollar, here also we need to add t dash gives epsilon. So that is over. Then next production is we will take as f gives left bracket e in right bracket. So first we will apply rule 1. First of f is equal to left bracket, so m of f left bracket, here we need to add f gives within bracket e. So f left bracket, here we will add left bracket, here we will add f gives within bracket e. Fine. Then we know that first of left bracket e right bracket contain only left bracket, so there is no epsilon. Epsilon is not belongs to, so not belongs to first of left bracket e right bracket, so we can apply rule 2. And the last production is f gives id. Here first we will compute first of f, which is equal to within bracket id, so we need to add m of f id which contain f gives id, so f gives id here, f gives id, so f in id we will add f id, f gives id. There is no epsilon in first of id, this does not contain epsilon, only id, so we can't add rule 2. So all production present in the grammar one by one we taken, and we applied the rule related to the construction of parser. So we got a parsing table, few entries in the parsing table we filled with the productions, and few entries are empty. So you can see this is an empty entry, this is an empty entry, it's an empty entry, and here these two are filled, then here these three are filled, remaining all are empty. See, these all are empty, that means there are many empty entry. So all these empty entry we will write error. Okay, so whenever a reference comes in this entry, and parser will report as error, that means the given string not belongs to the language of the grammar. That is why the parser got an entry in this error cell. But if it is referring to the cell which contain a production, then the parser will use that production to expand and construct the parse tree. So this is the way to construct the parse tree. If you can able to construct a parsing table without any conflict, then the given grammar, we can declare the given grammar is a L11 grammar. So what is it mean by conflict in this case is, if any cell contain more than one production, for example, suppose here you have E dash gives, E dash in the row and plus in the column. Suppose here you have two production, you got two production, then we can declare the given grammar is not an L11 grammar. We can't construct parse tree. So two production in the cell indicate that is a conflict. The parser can't decide which production to use, so it is an undeterministic situation. So the parsing operation can't perform. So the given, because of this grammar is not a L11 grammar, you can declare it. Okay, so here I conclude the session. So we have applied the rule to construct a parsing table for a given grammar. So like the way any grammar we can verify by constructing parsing table whether it is L11 grammar or not. So thank you for watching the video. Okay, thank you.